Hello everyone, welcome back. So today we will be solving our fifth problem, which is top k frequent elements. Given an array, integer array nums and an integer k, return the k most frequent element within the array. The test case is generated such that answer is always unique. You may return the output in any order. Okay. First let me explain the problem statement properly. So here we have an array and we have an integer k equal to 2, and this is the array. So we have to return the kth most frequent repeated number. So here if you see frequent elements within the array, so if you see here 1 is repeated only one time, 2 is repeated 2 times, and 3 is repeated 3 times. So that is are generated such that the answer is always unique. Okay, then the k most frequent, 2 more. Okay, so here we have to return, so here k equal to 2, so here we have to return two most frequently repeated numbers. So here the two most repeated numbers is 2 and 3, because 2 is repeated 2 times and 3 is repeated 3 times. So we will take this example also. So this is not a good example, but still here we need to return any one which is the highest repeated number. So here the 7 is the highest repeated number. Suppose here in this example, instead of 2, if it was 1, then the answer would be 3, because 3 is the largest repeated number. It has been repeated 3 times. Okay, now let's start coding. Okay, first we will be using priority queue for this. Let me have dictionary first, integer. Then we'll have priority queue. Integer pq equal to priority queue. Then first let's load the dictionary like this. For each var I nums, if dict dot contains key I, dict of I plus plus, else dict of I will assign an initial value. Okay. You can also use try get value to do this, but it's fine. Okay, now since the dictionary is initialized like this, now we'll initialize a priority queue. For each var kv in dict pq dot enqueue. Here enqueue is equivalent to addition, like adding the element to the priority queue. So let me explain priority queue before writing the statement. So priority queue. Okay, it is a data structure that stores element in a queue format where we can enqueue and we can dequeue. It is like in first in first out, but here the twist is it's based on the heap, like max, heap and min, based on the ascending or the descending order. So if the number is like 1 2 3 or like 4 like this, and initially priority queue will be like 1, it starts from the lesser value. So if you insert 1, it will be here. If you insert 2, it will be here. If you insert 3, it will be here. Okay, this is not the proper way to explain. Wait 1 second. Okay, queue will be like this. Okay, first in, first out. But this is not a normal queue. It is the queue which assigns the priority. So when you enter 1, let me change the example a bit. Instead of 1, I'll put it as 7. Okay, when you enter 7, it goes inside this queue. 7 will come here. When you enter 2, now 2 has the highest priority as the initial priority queue, So 2 will override this, so 2 will come in front of 7. Then again 3 is lesser than 7, so again 3 will override this 7, like override in the sense like come before 7, okay, like this. Then again 5 is lesser than 7, again 5 will come here, again 4 is lesser than 7. So this is how the priority queue works. So it has operations like enqueue. Enqueue means inserting the elements inside the priority queue, and dequeue means removing the elements from outside the priority queue. Okay, so this is how the priority queue works. Now priority queue.enqueue, but in other languages in Java you can enter only one value, like only one integer, then that is the value and that is also the priority. But in case of C#, we have to enter two values, one is value and one is the priority. Okay. Here I am entering the same value. Okay. Value will be key and priority will be value, because and this one I will keep in negative. Why negative? Because initial priority queue will be in ascending order, like the smaller ones comes in the first, but here we want the bigger one to removed first, so that's why we are keeping negative. Because -1, suppose if you have 1 2 3 4, if you all convert it into negative, -1 -2 -3 -4, now you can see -4 is smaller than -1, even though if we don't add like minus here, that if you don't add the minus, 4 will be greater. If we add the minus, -4 will be the lesser, so that's why we are adding here minus. After that we'll have a while loop, while k minus minus is greater than 0. This is a prefix operator, not prefix, postfix operator. So after each iteration k will be reduced. Okay, now before this we have to create a list integer, because the return type is integer. Okay, but we don't know exactly how much values we have to return. Sometimes the key, it might be lesser than k also. Okay, wait, let me try that. Integer is equal to new integer k, and also an index equal to 0, while k lesser than equal to 0, res of index, and also your postfix operation equal to pq.dq. Okay, return res. Let's see. Okay, it's working cool. Yeah, amazing, it passed. So now I'll explain the code again. Okay, first this is the dictionary code. So this will initialize 1 2 2 3 3 3. Yeah, 2 2 3 3 3. This is the input, and this will initialize the dictionary as 1 1 2 2 3 3, their particular value and their particular frequency. Okay, dictionary part is over. This is the priority queue part. So this dictionary we will traverse, and the priority queue priority will be 1 minus 1, 2 minus 2, 3 minus 3. This is how we insert, but after inserting the priority changes. So here the priority will be 3 minus 3, 2 minus 2, 1 minus 1, because this is the lesser number than the -1. So the priority order will be from lesser number to higher number. Although you can change this here by adding a comparator here, int dot compare dot default something. Yeah, I don't want to explain those complex things here. Okay, then the same thing. See, we have to return k equal to 2. We have to return 2 number. So this while loop we are initializing an array. After that, this while loop we are traversing, like we are iterating 2 times. So 2 times we'll remove this element from the priority queue. That's what your DQ is doing. After that we'll just return the array. That's all. That's all this problem is about. So if you have any doubt, or if you want method using this comparator operation, or using any other language, you can just drop the comment or anything. Yeah, thank you.